Hello everybody, welcome back. The last time I was just live for 3 minutes and then I got a call, and because of that thing I had to end there, then and there. Here I'm back again, and let's be live for 1 hour continuously. And in this particular live we are gonna be discussing about the topics mentioned in the title. So as simple as that. It's gonna be pretty simple and straightforward. Mainly we are gonna be talking about HLD related stuff. So let's see ultimately what we can do here. Here we are. Let me get some of those things, settings ready and all. Am I audible? Okay, I'm definitely audible. The fan is running in the background, hence there's gonna be some noise as well. So excuse me for that. And apart from this particular thing, everything else is gonna be fine. So without any further delay, let's simply get going. We just simply went through this normal intro. Then this normal architecture we have already talked about. So we are not gonna be discuss about all these things, exactly how the overall architecture looks like. So if there's any app, this is how the overall architecture looks like. So you will have a normal web, then there's going to be load balancer. There are going to be different data centers. In those data centers there are going to be different servers. So there are going to be group of servers. Similarly, there are going to be many databases. There may be a shared DB as well. There's going to be message DB, not message DB, messaging queue implemented. There may be some proxy as well, ultimately CDN. So yeah, there are a lot of things that uh, get implemented in this particular case. By the way, this is not even we are going to be talking about. Cap theorem we have already talked about. So ultimately, cap theorem, the full form is consistency, availability, and partition latency. I hope that's partition latency. You always need partition latency. Partition latency in the sense whenever a client makes a request, you get the response. Okay, so let me just go through this. So ultimately, yeah, not partition latency, that is partition tolerance. So our application should be always be up and operatable. That simply means whenever a client sends a request, you get the response. Consistency and availability, you can just choose one of them. You cannot get both of them at the same time. So this is what we discussed, and then at last, not this one. This is the section actually. So, oh, I hope this is the one. So first of all, we discussed about cap theorem, and after that we started talking about monolithic and microservices. Monolithic means your whole code is written in the same file and all, and microservices means you have different microservices, different services for different tasks, and they are just simply connected together. And when it comes to databases, so there are two types of databases: shared and unique. Again, whether you want to use shared DB and unique DB is completely up to your use case. And then we have communication. We have unique DB, orchestrator, writing transactions, event driven system or orchestrator, writing transactions. What does it mean? What does it mean anyway? I was the one who wrote it. First of all, you have event driven architecture, that is for sure. So ultimately, when you are using multiple DBs, so you will have to make sure that there is some kind of transaction that is being implemented. Again, we are not going to be talking about this thing right now, but yeah, this is something you have to keep in mind. And master slave architecture, that's fine. I mean, good enough. Again, we have already talked about all these things, so it's not the right time to just simply go deeper into them. Ultimately, we have talked about normal architecture, we have talked about cap theorem, we talked about back of the envelope, ultimately BOE, monolith versus microservices. Even we have talked about databases, where you should use shared DB, where you should use different databases. So ultimately, you should horizontally scale the database. And we have even covered DB sharding and load balancers. DB sharding in the sense, what is the best way of sharding the DB, and there are two ways mainly. First one is using hashing function. So ultimately, there will be many databases. You will be hashing. You will be getting a number, and then you will get the modulo of that number. On the basis of that thing, you will just decide which database is gonna be used. This is the first way. Second one is the consistent hashing. Ultimately, this is also one of the ways to just simply kind of horizontally scale the database. And there are load balancers. When it comes to load balancers, so there are some algorithms for the load balancers. On the basis of those algorithms, your load is actually balanced. So one of them is Robin Hood algorithm, round robin algorithm actually. Then weighted round robin algorithm, and there are more actually. I've forgotten the. Let me go till the end. Yeah, the other ones. So ultimately, when it comes to algorithms, so there are two types of algorithms: static and dynamic. In the static, round robin algorithm comes, weighted round robin algorithm comes, IP hashing comes. So IP hashing in the sense, based on your IP address, your load is going to be balanced. Ultimately you will be assigned a server. When it comes to dynamics, so we have list method, list connection method, weighted list connection method, least response time on the basis of the least response time, or resource method. So these are some of the algorithms that that get used. So ultimately when it comes to this, so we have two sections here. We have static, we have dynamic. When it comes to static, so we have round robin, weighted round robin, and we have IP hashing. So these are the algorithms. And then in dynamic we have least connection method, and then we have weighted list connection method in the sense, whichever server has the least connection, that will be assigned a new connection. I mean, a new request will go to that. Weighted list connection in the sense, it will take care of the weight. On the basis of the weight, the connections are gonna be assigned. This particular server can handle these many connections. Weighted, if it has more weight, it can more weight in the sense more power in that, so it can handle more weight, more requests and all. And then we have least response time, whichever is taking the least amount of time, that will be sent the request. I mean, request will be sent there. And lastly we have resource method. Ultimately this resource method in the sense, it is sort of a combination of everything. So there are agents in your server running. Those agents are gonna tell you whether server can actually handle that this much these many requests or not. If that server can handle, the request will go to the server, otherwise the request will not. So these are the things. When it comes to load balancer, we have application level load balancer, network level load balancer, global server load balancing, and DNSLB. Okay, let's talk about this application level load balancer. So on the application level, your request is actually sort of balanced. Suppose in that particular case you are using HTTP and HTTPS. On the basis of the protocols, ultimately your request gets load balanced. On the network level, based on the IP address. And then on the global level, suppose global level in the sense, you have whatever, you have your website running, and there are different data centers in the different part of the world. So one of them is in India, another one is in USA. So there's going to be a top level, global level load balancer. So first of all, the request will go to that particular load balancer. From there, the request will go to that particular region. So this is how it's going to be going on. And then we have DNSLB. DNSLB in the sense, once you make a request, the request goes to DNS. DNS gives you the, of course, the IP address and all. Even from there, you can just simply load balance the request. So these are some of the things. Again, will not be diving deeper into them. We have to talk, we have to mainly talk about these 7th and 8th point properly in a proper way. Apart from this, we are just simply kind of having a recap, nothing else. Rate limiting. There are some algorithms for the rate limiting as well, especially if I can remember. So a rate limiting algorithm. So there is something called why am I forgetting them? Bucket. What bucket? There is leaky bucket method. So there is a leaky bucket. There is one more. I am forgetting that. So ultimately over there you send the request. Yeah, token bucket. So ultimately what happens? You send a request, and there is a token generator. So that generator keeps generating the tokens. And if a request gets the token, request will be forwarded to the server. Otherwise, request will be dropped. So I hope that is called a token bucket method. Then we have leaky bucket method. So token bucket method, leaky bucket method, and then the next one is the fixed window method. Fixed window method in the sense, there are going to be fixed intervals, and in those intervals there are going to be fixed number of requests that are going to be allowed. So this is also one of them. Then we have what is that called? Sliding window method. So ultimately sliding window in a sense, there's going to be a fixed intervals window, and that will keep sliding. So whenever you get a request, you will check back sliding window log. So you will check back from that particular time that, okay, in previous 1 minute have I got how many requests I have got. Is that more than I should be getting, or is that less than I should be getting? If that is less than you should be getting, the request is going to be forwarded. And lastly, we have the combination of both. We have the combination of fixed window and sliding window log, and the combination of these is going to be sliding window sliding window, whatever. I am forgetting the name, but ultimately there's a combination of both these algorithms, and a new algorithm is created. In that algorithm, what you do, again you have a fixed window, a fixed interval of suppose 1 minute, and whenever you get a request, So first of all, we have a lot of fixed intervals, and whenever you get a request, so from that point of time, you just simply go back 1 minute, you go 1 minute back, and over there you check that how many requests you got in the current window and how many requests you got in the previous window, and then current window, whichever number of requests you got, plus what you will do, the requests that you got in the previous window multiplied by the percentage of the requests that are there in the previous window. Again, this is confusing, I know. So ultimately what you do, you get the number of requests in the current window, you get the number of requests in the previous window, you just simply add both of them. Once they are added, you check whether that crossed the limit or that is less than the limit. If that crossed the limit, that's gone, of course you will have to drop the request. If that did not cross the limit, that will be allowed. Okay, enough of the theory. Let me just simply show you the real names of them. Because of course if I try to remember them on my own, few names are gonna be here and there. Token bucket method we have, leaky bucket method, fixed window counter, sliding window log. In this particular thing, what you do, you actually maintain the log that okay, you got a request at this particular time, go 1 minute back and check the number of requests, check the logs of those requests that you got. The log is gonna be telling you the information about the request that you got. So in this particular case, what you have to do, you have to actually maintain the logs of the request. Hence it's gonna be of course expensive, I mean CPU expensive, or you will have to spend more for this. Hence there's the last one, sliding window counter. This is the combination of both. So here what happens, you have a fixed window, there are intervals. Whenever you get a request, you go 1 minute back, you check the number of requests, but in this particular case logs are not maintained. Rather, how you do that? First of all, we do not really maintain the logs, and we do not maintain the log, but we do keep the number of requests that we get. So ultimately what happens, you just go 1 minute back, and it could be that in the current window only you got the current window is the 1 minute block, or it is the combination of two windows, and you just simply check like number of requests in the current window, number of requests in the previous, add both of them and check whether that actually crosses the limit and all, and this is how it's gonna be going on. The only difference is that in this particular case you have to maintain a proper log. In this particular case you do not have to maintain the log, rather you have to just simply make sure that in 1 minute's interval get the total number of requests, and if that crosses the limit, then alrighty, I mean drop that. If that does not, do not drop that. So this is how it's gonna be going on. But one thing is missing, one thing that I'm not sure about, that is sliding window log. You are actually maintaining the log, that simply means keeping the info about the request. And sliding window counter, in this particular case what you are doing, that I think this is the one, not this one, this is the one. So here you are saying that these are the intervals. First of all, suppose 1 minute's interval, and this is the sliding window block that you actually ultimately have, and 1 minute's interval, and 30% request you got in the current one, 70% request you got in the previous one, and then you are just simply sort of getting the number of requests and adding them. So still sort of you have to keep these many requests in memory, then only you will be able to calculate. Okay, never mind, let's continue. So these are the things. By the way, when it comes to rate limiting, so there are different kinds of rate limiting: client side, server side, middleware. You can just implement it on any side. What is this? Just a sec. Okay, here we go. Okay, and then on the basis of the either IP address or user ID or something else, completely up to you. Like whenever you get a request, you can just check the ID of the user, and a user with the same particular ID should not be able to make a request, I mean should not be able to make requests over and over. And this is how things are gonna be going ahead. I may have to actually turn my camera off because there are gonna be people around me, but let's see. If I have to, of course I will, or let me just do that right now. So the camera is gonna be off for now, and I will still be speaking here. So we've talked about this particular thing. So this thing is done. When it comes to caching, so of course you can just simply cache the things. I don't even know whether I talked about the caching over here, but caching can actually be implemented here. So ultimately if something's being used over and over, so caching can be used. I haven't talked about these caching strategies, but never mind. As for right now, I don't really think I have to turn it off, so let me turn it back on. Okay, then we talked about like a URL shortener. URL shortener in the sense how you just design a overall URL shortener. And first of all, this is one of the most important things that you have to keep in mind. Having said that, let's talk about this. This is the most important thing, and remaining things are fine. Whenever you just do the back of the envelope calculation of anything, so ultimately you need to keep these numbers in mind, otherwise it gets a bit tricky. So ultimately, if I mean, most of the time what your goal is that whenever you are doing calculations, you have to just bring it back on 2 to the power format. So you'll have to make sure that whatever calculation you are doing, make sure that convert that into 2 to the power format, hence it gets easier to just manage the things. So ultimately, if 2 to the power 10, that is called kilobyte, that is approx 1000, and hence this is called you can call it 1000 or 10 to the power 3 bytes. This is done. 2 to the power 20, that is around this is called 1 megabyte, that's equivalent to 1 million, not exact but around. 2 to the power 30 gigabyte, and of course 1 billion approximate again. 2 to the power 40 terabyte. So ultimately 10 kilobyte, 20 megabyte, 30 gigabyte, 40 terabyte, 50 petabyte, and 60 exabyte. So this is how it just simply keeps going on. And these numbers you have to just simply keep in mind. So 10 kilobyte 1000, 20 that's the megabyte, and that is of course 1 million, 30 gigabyte 1 billion, 40 terabyte, and that's equivalent to 1 trillion, and then terabyte trillion. At least they are sort of similar, terabyte trillion, they both start with a T. And then 50 petabyte, and that's called quadrillion, and then quintillion. That's crazy name, but okay, never mind. So this is what you have to keep in mind, and I'll have to turn the camera off, of course, right now. Close the door. Just a minute. दरवाजा बंद कर दीजिए. Okay then, let's continue. And the next thing that we are gonna be talking about here, that are the bits, and the bits are simple, quite simple to understand. Ultimately, there are gonna be bytes. Byte, like 1 byte is equivalent to 8 bits, and then 10 to the power 1024 bytes 1 KB, 1024 KB 1 MB. Ultimately, it just simply keeps going on. So let's not worry about this. Okay. So this is how we were talked about these things. The important thing actually starts from here. 07, ultimately 7, designing a notification system, and then messaging queue. So let's simply go through this. Again, I will be going through this particular thing from scratch, and if needed, we are gonna be just, what has the light gone? Okay, never mind. So we are gonna be just simply talking about this, and if possible, we are gonna be drawing the diagrams as well. So let's see how it's gonna be going on. So this is it, and we may need to just simply draw some of the diagrams talking about this notification system. So there are a few things. First of all, the things that you have to keep in mind, that is just a sec. There are a few things. First of all, whatever system you are designing, so it doesn't matter what kind of system that is. So system design, we are gonna be talking about this particular thing over here. So first of all, you need to ask questions related to that particular system, like exactly whatever information you need to have regarding that, you should have the information. Second, you have to just simply get the back of the envelope calculation done. So BOE cal, just a minute, give me a second. Okay then, let's continue, and just a minute, give me a sec. I did not really turn on the, okay, let's turn both camera and mic. So ultimately, these are the things that I was simply talking about. You need to first of all ask questions, and once you have asked questions, you have to get a back of the envelope calculation done. And lastly, once all these things are done, then you have to just think of the system design. So ultimately, you have to start designing. So first of all, you have to ask questions, then you have to get the calculations done, and then you have to just simply start designing based on the calculations and the questions. So this is how the things, overall things are gonna be like. So without any further ado, let's simply get going. So first of all, let's see what I've done here. So ultimately, when it comes to notification system, so what are the type of notifications? So let's just simply get these things mentioned here. So first of all, types of the notifications. So we'll try to just get the things done from our on site. When it comes to, just a minute, I think I need to do it like this. Okay, so when it comes to the types of notifications, so there are SMS, email, and in-app notifications, right? Push notifications, MS, email, in-app. They are the mobile notifications only. So we have mainly three types of notifications here. First one is SMS, second one is the email, one is the push notification. We can talk about these things verbally, can't we? So these are the types of notifications we are going to be having, and there is something called real-time system and soft real-time system. So real-time system in the sense you should be getting the data. First of all, types, there are going to be email, there's going to be, just a minute, there's going to be email, there's going to be SMS, and the third one is going to be in-app. So ultimately app will be just simply sending you the notifications and all. So this is how you are going to be going ahead with the things. People are actually going to be sleeping around me, so I better just simply get it done really quickly. So let's see whatever we have to cover. It's not really possible to cover everything right now, because of course there are people around me and I'll have to no doubt get it done. But ultimately what we are doing, we are just simply knowing about our applications. Once we know about our applications, then we are doing the back of the envelope calculation. Again, we are assuming the things over here. Once the things are assumed, then first of all we are calculating it. We will do this calculation on our own. So we are going to be just taking care of this thing as well. Lastly, we start designing the system. So whatever the requirement is, on the basis of that thing, we start thinking how it's going to be going on. And when it comes to notifications, so let me show you the last thing. This is the one of the most important things that you have to keep in mind. So there are going to be many services. What are those services? They are sort of the I can just simply say that those services just simply request to send the emails. There can be any service that may request to send you request you to send the email. So ultimately it just simply sends the request to the publisher. This publisher is mainly responsible for generating the body of the request and whether rate limiting or authenticating the request, whether that's the right one or not. And then once it just does all these things, so it will just simply send the request to the messaging queue, because again it just simply gets the request, authenticates and all, and then it just simply sends those requests to the messaging queues. So this is sort of a publisher. There are messaging queues, there can be many messaging queues. We are going to be talking about them. And those messaging queues, they have workers. They are actually called consumers. So workers, they are going to be getting the whatever requests are there in the messaging queues one by one, and in their at their own pace, they will be just simply getting those requests resolved, and they will be just simply sending the acknowledgement. So this worker will tell to the messaging queue whether the request that it resolved, that got succeeded or not, and at the end of the day, if everything goes right, the request is going to be sent to the client. So this is the overall flow that goes on, and there can be some caching related stuff as well on the publisher side. So there can be notification DB, because we have to definitely save some data in the DB as well. These are the notifications that actually got sent, and there can be some caching data as well. And at the end of the day, there is something called analytics service. That simply means it will know about the request from the publisher side, it will know about the request from the messaging queue side, it will know about the request from the worker side, and probably from that kind of request it is sending. There are different kinds of services in different devices, suppose in Android or in Apple and all. And in Android we have FCM, in what is that called, iOS we have APN, we have Twilio for sending email if I'm not wrong, and we have MailChimp. I mean, they are used for different things. I think MailChimp is used for email, and Twilio is mainly used for SMS and all. So we are going to be talking about these things. So ultimately an analytics service just simply gets the analytics from everywhere, and that keeps it saved somewhere, probably in the DB and all, somewhere or the other. And when these things are actually saved there, and then on the basis of that particular log, you check how your system's behaving. Suppose publisher published the event or an event ultimately, but that MailChimp or any sender could not send the email. So ultimately this way you will be able to check whether the problem is occurring at the worker level or at the publisher level or at the uh, service I mean sender level. So this way you can just simply get the things done. Again, we have to talk about all these things in detail. Unfortunately, this is not the right time, so this is one of the things that we have to discuss tomorrow. And last thing is that we have to talk about messaging queues and pubsub. Messaging queues in the sense how this messaging queue actually works. So let me get it done briefly here. In messaging queue you have a few things. Let me talk about this. So not this, probably this one here. So in messaging queue you have a broker in the sense that's gonna be the top level. There can be many brokers. Broker is nothing but sort of the environment. Ultimately the top level thing is called broker. Inside the broker you have many topics. There can be many topics. Those topics contain many partitions. So this is the one partition. Similarly you can have many partitions, and those partitions have there is something called offset. So the way we have indexes in array, similarly this partition have offset. So offset 1 0 1 2 3, it will just simply keep going on. And then there are consumer groups. There are consumer in the consumer groups, and there is a there is a specific use case of each of everything over here. So we are going to be talking about that. And there is zookeeper. This zookeeper is mainly responsible for checking whether how many kind of events this worker has resolved and how many of them actually remaining. So we will be talking about these things anyway, but overall this is how the overall flow looks like. So let's have this goal for tomorrow. I just wanted to go live because I couldn't even yesterday, so I just thought of going live somehow today. That doesn't mean that the learning is not going on, that is, but sometimes it gets hard to just simply I mean lazy, what laziness you must be aware of. But never mind, from tomorrow onwards, even in the early morning, I'll make sure that I'm just simply going and discussing about all these things. Until then, bye bye. I think this should be enough. We have to cover these things. And then as for the to-dos that we actually have a lot of to-dos. A lot of to-dos in the sense, here we go. We have to talk about Kubernetes scaling. We have talked about the deployment. We have done this as well. Once we deploy, how the scaling happens, we have to go through this. HLD I already talked about, and there is something called V-test that I have to learn and then I have to talk about. So these are the few things that we have going on right now, and then we are going to be talking about all those things. As for right now, I'm just simply going to be calling it right here. Sorry for that. Hopefully we are going to be catching up soon. Until then, bye and take care.